This video is the demonstration of plane strain analysis. A mechanical structure can be treated as a plane strain problem if the strain along the z direction or normal to the xy plane is 0 and the shear strain in xz plane or yz plane is assumed to be 0. The condition for the plane strain analysis is when we have the mechanical structure whose length perpendicular to the xy plane is larger in comparison to the dimensions in x and y. Also, the loading is perpendicular to the z-axis and loading is uniform throughout the length. I repeat, the loading should be perpendicular to the z-axis and should be uniform throughout the length. And also, the cross-section of the geometry at any point should be same, which means the structure should not have the variation in its dimension along the length of the structure. Let us begin with the tutorial. Create a new static structural analysis file. Rename the file as 2D plane strain. Enter. Pick on the geometry, right-click, press hold, pick on Import Geometry and select the plane strain part file. Right-click on the geometry again, pick on the properties. Ensure that the analysis type is two-dimensional. Once the property is set, right-click on the geometry and pick on Edit. The geometry will be opened in the Design Modeler now. You can find the message at the bottom left corner, Starting Design Modeler. Select the ANSYS Workbench unit as millimeters. Pick on OK. Maximize the Design Modeler window. Reset the window layout. View, Windows, Reset Layout. You can observe the geometry is attached but is not imported yet. Hence, use the analysis type in the Advanced Geometry option as 3D and pick on the surface bodies as No, which means we don't want to import the surface bodies. We are interested in the solid bodies. Line bodies, no. Now pick on Generate. The geometry will be now imported. We need to convert this model into 2D model. Hence, we extract the mid-surface. Pick on the tools, mid-surface. Select the front face and the back face of the first model. Pick on Apply. Pick on Generate. Mid-surface is extracted and the solid body has disappeared. Similarly, pick on the tools, pick on mid-surface. Pick on the front face and the back face of the second part. Pick on Apply. Pick on Generate. The mid-surface is now extracted and the solid bodies have disappeared. Orient the view to front or top or as per the requirement. In this case, we are interested in the front view. Once the geometry is been simplified, we need to import this geometry in the mechanical window. Open the project page and open the model. For pre-processing and solution, right-click, Edit. The mechanical window is now starting and the 2D geometry is attached to this mechanical window. Pick on the geometry and change its behavior to be a plane strain behavior. You can observe that the coordinate system is lying exactly at the center of rotation of this model. The objective is to rotate this body and evaluate the stresses and the deformations coming onto this part as well as the whole assembly. In the view of that, ensure the connections. There is one contact region which is identified automatically with a predefined pinball radius. We are interested in the contact of all the edges of this body with this cam. Hence, we are going to redefine the contacts and targets. For time being, hide this body. Pick on the face here, select this face, right-click, hide body. Under the connections, pick on the contact and ensure that the edges are selected. Right-click, press hold, select all the edges to be in a contact and unselect the inside edges. Pick on Apply. You can observe a red color border for this model, which is nothing but a contacting area or the contacting curves. Right-click, Show All Bodies. Under the target, we are interested in only this circular profile because apart from this profile, there is no geometry of this cam which is going to be in contact with this rotating body. By default, the contact is taken as bonded. We need to change it frictional so that there will be a relative motion between two bodies. Pick on this contact, change its type to be frictional. For the smooth operation, give a small amount of coefficient of friction. the contact behavior need to be changed to symmetric. Also, the formulation to be augmented Lagrange or pure penalty. Any of the formulation can be used for this analysis. Under the detection method, use node normal to target. Under the interface treatment, select add offset no ramping. Under the normal stiffness, use manual and enter the stiffness value as 0.1 for this contact. Update the stiffness during the simulation or each iteration. Pick on the analysis settings. Enter the automatic time stepping as on. We want to capture many intervals during the solution process. Hence, we will enter here around 1000 time steps we want to capture. The minimum time step will be 200 and maximum will be 1000. Make sure that the solver type is direct solver. Switch off the weak springs. Switch on the large deformation effect. Once the necessary analysis settings are done, let us proceed for meshing the model. Right-click on the mesh. Insert, pick on sizing. We want to give the element size of 1 for these two bodies. Hence, ensure that the surface is selected or the body is selected. Pick on these two bodies. Pick on Apply to confirm the geometry. Under the element size, enter the value as 1. Pick on this body, right-click, press hold, generate mesh on the selected bodies. Similarly, proceed for the second body, right-click, press hold, pick on generate mesh on selected bodies. To check for the quality of the mesh, pick on the mesh. You can observe this is the mesh which has been created. We'll come back to the contact and define one more parameter called as pinball region. Currently, the pinball region is program controlled. We'll change the radius to 0.2. millimeters. Once the contact is defined, mesh is generated and analysis settings are done, it is a time to define the load and the boundary conditions. The boundary condition being, for this cam body, this whole area need to be fixed. Right click on the structural, pick on insert, use. Fixed support. Zoom the area where you want to give the fixed support. Ensure that the edges is selected in the selection filter. Pick on this edge. Pick on Apply. This cylindrical or a circular hole is now constrained in all degrees of freedom. Now let us give a rotational degrees of freedom for this body, that is called as remote displacement. Right click on the static structural, insert, pick on the remote displacement. Remote displacement should be given for all these curves. Hence, hide this body. Right-click, pick on Select All. All the borders of this body are now got selected. Pick on Apply. We have to restrict its motion in X and Y component, and the rotation should be given as a constant value, say 360 degrees. Which means this body can only rotate in 360 degrees and will not translate in X and Y axis. Ensure that the values entered here are correct. Now insert the results of interest. Right-click on the solution, pick on the insert, pick on the deformation, directional deformation. Similarly, right-click, insert, stress. Use von Mises stress. Please note that the material which is used for both the bodies is steel. Cross-check for the geometry and treat this geometry as a plane strain model. Also, the contact is defined as a frictional with the less coefficient of friction and a behavior, formulation, detection method, normal stiffness, and the pinball radius. The meshing is defined with the element size of 1. Necessary analysis settings of initial substeps minimum and maximum are provided. The solver type is selected. Weak springs is switch off the weak springs. Next, large deflection effect should be on. Once all the settings are done, ensure the boundary conditions given. Fixed support. The highlighted edge is constrained in all degrees of freedom. Similarly, under the remote displacement is given for the outer edges of the rotating body. Once all the conditions are ensured, it is the time to solve the problem. Right-click on the solution, pick on Solve. You can observe the ANSYS solution status. Under the solution information, pick on the force conversions, which will dictate how the problem is going to be solved, the number of iterations which are completed, and the current time step which is running. This can also be monitored in the output window. This problem will take around 10 to 15 minutes of time. Once the solution is completed, it is a time to retrieve the results. Directional deformation. Let us observe its behavior. Pick on the graph, pick on Animate. Observe the behavior carefully. The contact is detected. and the behavior is as predicted. Similarly, the stress can be evaluated. Pick on Animate. This is how the stress distribution is happening in the assembly. The stress which is coming at the contact region. The stress which is happening due to the bending of the scan. Thank you for watching this video. For more videos, please visit and subscribe my channel. If this video is helpful, please press the like button.